quite a while now. I've kind of had my eye on it, but I haven't really gotten around to doing anything with it until quite recently. And so I've decided to redo some of the LeetCode 150 problems in Rust just to get a better feel for things. And so I've done this a little bit before in C Sharp, but I decided to reset my progress and redo it from Rust from the start. And so here's the arrays and hashing. I've still just only done 5, but it was actually this morning whenever I did this top K frequency elements problem that something interesting happened. And that's what I want to share with you today. And so let's break it down. The top K frequent elements. This is still very much an easy problem. Nothing crazy happening. We're just taking an array of integers and given K, return the integers ranked by their frequency. So this guy would return 1 because 1 happens 3 times, which is the most out of anything, and then next we'll return 2 because it happens the second most frequent. So not crazy. We take the nums and then we take K and then we just return these nums ranked by their frequency. And so here's my solution. But first, before we get into the solution, I gotta say that, guys, the rumors are true. Rust is blazingly fast. These are my C# solutions from a couple days ago. And then this is my correct solution of just this morning. And my optimal solution ended up being 125 milliseconds. And then I don't even know how fast this is because I assume that they're just rounding up. And so I don't know. I'm just going to assume let's just say it's 1 millisecond. And so even if it's 1 millisecond compared to my C# solution, I mean, that's over 100x improvement. And what's crazy is that is by no means a cherry-picked or contrived solution, in that my C# solution beats 80% of the other C# solutions. And so you can see here, I wasn't trying to make a cherry-picked compare contrast between the languages. I definitely tried to optimize this as much as possible. There's still some room to go, but that's just crazy that it is that fast. And so and even the memory, it's like a 20th of the megabytes of the memory. So that was something that was really cool. I'm still shocked at how fast Rust is compared to memory managed languages. I knew it was fast, but until I saw it for myself, I still can't get over how fast it is. And this kind of means a lot to me because in the past I've done a lot of projects in C# where I would have killed for even just like a 2x improvement in speed. I've done a lot of toy games, and I've done some pretty algorithmic and data intensive projects as well in C#. And to think that I could get such an improvement by going into a non-memory managed language, that is, I'm still getting over this. I'm sure this is obvious to a lot of you guys, but I still can't get over this. But anyways, that's not why I want to do this video, but that was just something really cool that just shocked me. But let's get into the actual problem. And so the problem is really 2 parts. The first half is that we just go through the numbers. We go through the vec of integers, and we, in this section, we just load this hash map of numbers by looping through this. And the key in the hash map is the actual number in the vector, and then the value is actually going to be the frequency. So as we go through it, we basically are incrementing the frequency of the hash map every time we see that specific n. And so that's just what this is doing. And then here, this last half is we're just converting the hash map to a vector of pairs, where this is once again the number and this is the frequency. And so we just sort it descending based on the frequency, and then we just take the top K, which we grab from here. So overall, nothing really crazy, and so I wasn't expecting any trouble because I'd done this before, and I was just redoing my C# solution that hadn't really taken much time, and so I wasn't really expecting this to be difficult, or wasn't expecting any troubles. But when I went to submit it, I first ran it, and everything passed. The two simple, trivial base cases were correct. This is obvious. I'm not surprised that passed, but this guy passed, and so all good so far. But whenever I went to run it, it failed. It failed the extensive test suite. As you can see here, there's 21 test cases in like the submission test suite. If you don't know about LeetCode, you kind of get this little base case here, and you can run it quickly, and then when you actually go to submit it, it runs a big suite of pretty extensive stuff. So it failed this one, and so I was shocked because I couldn't believe that it passed these guys and failed the extensive list. So actually, to be honest, I thought that it was a bug in LeetCode's on their side, which is kind of funny because I don't know, I just couldn't imagine that my code was wrong. So my first knee-jerk reaction was like, no, it's LeetCode, it's their problem. And so what I first did is I changed my solution so that I wouldn't mutate the input vector. And the reason I thought it was LeetCode's problem is because I was changing the input vector, and I did so knowingly. I did it just for a little bit of speed up. So I knew that if I could change this in place rather than copying it and then working on the copy, that I would get a little bit of a performance boost. But I thought that it was LeetCode's bug because I thought that they were only creating one vector for every test in this suite of tests. And so, which doesn't actually make sense in hindsight, because then I think these guys would have failed. But that was my first knee-jerk reaction. I still can't believe I didn't think my code could be wrong. And so what I did is I actually changed the for loop to stop mutating the input vector. And I changed it. I basically, made a copy iterator, which doesn't change the input. And so I was like, okay, LeetCode's problem, but I'll work with them and not mutate the input. But it was actually my problem, not LeetCode. Surprise, surprise. And so my slight addition or change where I don't change the input vector, it still failed. So at this point, I couldn't even believe what was happening, and so I'm starting to come to terms with my code might be the problem, and so I did figure it out. But it is really kind of a fun bug in that, like I said, it fails the big suite of 21 test cases, but it passes. It passes this. That doesn't surprise me that this passes, but it passes this, which is a little bit, it's slightly non-trivial. And so I'm going to invite you to pause the video if you want and try to find the bug. And it's not like a crazy bug. It's actually a very small change. But I thought it was really cool that I was able to introduce a bug that passed these simple cases, but it fails the the extensive suite. And so with this in mind, and looking at this code, I'll let you guys pause it and see if you guys can find the bug without me telling you. So I'll give you a moment. Anyways, I hope you guys got it. If you didn't, the bug is actually in this section. So here I correctly load the map. The keys are all the value, the actual numbers, and each key has the appropriate frequency for each number. And so this all works perfectly, but the bug is actually down here. And so what I did is, the bug is that I use the key whenever I should use the value, and I use the value whenever I should use the key. And so here, I go to sort the pairs, but instead of sorting them by frequency, which would have been V, I actually sort it by the value itself. And then when I go to map it, when I go to extract it to return the number, instead of returning the actual number, I instead return the frequency. And so the fix is actually this. I simply just switch these two. And so if we see here, this works, this doesn't, this works. And so if we go to the trivial test case, this works because one only happens once. So even though I am returning the frequency and not the value, it still works because the one only happened once. So if I had an input array of 2 2s, that I think that would have passed 2. But if we go here, this is kind of the crazy part that this passed. So let's break this down. So here I correctly do the hash map. So that's fine. But here when I go to sort it, I sort it descending, not by frequency, but I sort it by the actual value. So 3 is first. And since 3 happens once, I first return 1. And then 2 is the second highest value. And so if, and so 2 happens twice, and so I return 2. Whereas I should have, returned 1 because it happens 3 times, and 2 because it happens twice. And so that still passes, even though it just completely isn't working. I mean, it only passed 4. So yeah, I just still think that's crazy that it was able to pass this, but not the others. And I think as I was doing this and as I solved it, I think that I wonder if this is intentional. If it is intentional, I'm like, I thought that was pretty awesome that they found 2 trivial test cases that would trick me into thinking that my solution was correct and then submitting wrong answers. And so if you don't know LeetCode, like I can't delete these, I don't know how to delete these, so it's like permanently on my account. So I feel bamboozled in submitting a wrong solution. But I love how I love that, how I was able to be tricked into thinking that my solution was correct. And so, but yeah, I switched the 2 variables and it works correct. And then here we go. And so I thought this was really cool. It doesn't even, my correct solution doesn't even hit 1 millisecond, and it beats 100%. Well, it ties for first place. And the other Rust solutions range from, under 1 millisecond to 4 milliseconds. It doesn't quite beat, my solutions don't quite beat the memory, but I think that what's happening here is that people are submitting, half the people are submitting like brute force, double for loop sort of, very terrible speed-wise solutions. But, like a bubble sort is what I'm thinking is an example of something that is really memory efficient, but no one uses bubble sorts because it's, it's like exponential, complexity. But so I'm not really winning in the memory department, but I'm telling myself that people are just doing bad solutions, but with in-place memory. But look at this speed. Look at this speed. That's not it. Look at this speed. My C# solution that was optimized is 125 milliseconds, and it's not even 1 millisecond. Anyways, well, I really enjoyed getting bamboozled by those test cases and figuring that out. I hope you guys enjoyed that, and definitely check out Rust. It's a blast and it's fast.